All right, so relations and functions. We will look at graphs of functions, how to identify functions, and then like writing functions. Writing the functions will kind of come more in the story problems ones too, so this will kind of link into the next section as well. So first thing is a relation. It is any set of pairs of input and output values. Okay, input and output. Now they can be shown in 4 different ways, and I'm sure you've probably seen at least 3 of these ways before. First way is ordered pairs, right? We know ordered pairs, X and then Y. Table of values, I'm sure you've seen XY tables before. I'm sure you've plotted points before. The one you may not have seen is a mapping diagram, where if you guys look, if you look at your ordered pairs, right? -3 is paired with 4, so -3 draws an arrow to 4. 3 goes to -1, so look, I showed you 3 goes to -1. But then 4, since it had 2 different options, it just drew an arrow to both options. Okay, so those are a mapping diagram. I don't know. That's what they are. I don't use them all that often, but you may not have seen that one before. All right, so then with inputs and outputs, other words for those is domain and range. Okay, so which one is domain, you think? That's X. Is it input or output? That's input. X is always the input, because what are you always plugging values in for? You plug in for X to figure out Y. So your input are your X values, or it's your domain. Okay, range is your set of output, or the Y values. Now, to help you remember which is which, okay, think alphabetical order. In the alphabet, D comes before R, I comes before O, X comes before Y. Okay, so hopefully that'll help you remember which one is which. Domain comes before range, X comes before Y. So X is my domain, range is my Y. Okay, so name the domain and range of the relation. So for number 1, D, we can just say D for domain. What are the domain values? Very good. What did he just list for me? The X values. Yeah, he just listed all of the X's. That's your domain. And then range would be what? Etc. Is that what you just said? Right, so 14, 7, 0, -18, -99. Right, so domain is all the X's, range is all the Y's. Pretty easy. It doesn't get much harder than this, honestly. This section is not necessarily hard, it's just knowing the terms that they're using, so you just understand what they're asking you. A lot of it is, just understanding what it is. The math today is not hard, guys. Okay, so number 2. Harley, can you give me all the domain values? Ooh, what do you notice Harley did not do? He didn't say -4 twice. Does he have to? No. It's still -4, no matter how many times he tells me -4, it's still a -4. Something like that last one. You can, it's not wrong. But I'm lazy. I'll write it one. All right, and then Mackenzie, you want to give me the range then? Oh, she did the same thing, lazy person. Mathematicians are lazy, and I love it. Right? Because we had -2 was actually listed twice, but you only had to list it once. All right, how are we feeling so far? Like this section, right? It's an easy one. All right, you do not have this in your notes, just for you guys to look up to me. Yeah. This honestly is like the way I remember learning about functions when I was in school, so I wanted to show it to you guys. The magic number changing machine. So what this is, I think of functions as a machine. If it is a function, it should work the same way every time. Okay, so like if I'm putting in, let's say, an 11. I plug an 11 in, that's my input, that's my X, I'm going to plug it in. the machine's going to do something, and out pops a 22. So it was multiplied by 2. Okay? Yeah, I could.
Where can I get this machine?
I made it. All right, what if I put in a 9? And I put in a 9. It's going to do something, and out pops a 54. It was multiplied by 6. No, it's right there. Okay, if I take a 15, I'm going to put it in the machine. It's going to do something, and I get a 24. So let's put it back up there. If I put in a 22, I can. It could have been either one. I think the first thing you guys said was that one, so I'll throw it on there. What if I put in a 77? 77 and I get 6. I subtracted 11. If I put in a 12, I got 24. I multiplied by 2. If I put in a 36, 18. Divide by 2. If I put in 100, 89. Good. Put in a 3, I got an 18. Multiplied by 6. 42, and I get a 21. I got a 31. I got a 40. Oh, I did. Thank you. What about this one? I don't know. Let's put it back through. It was a 31. Good. I added 9. And I have a 4.
Put it back for.
And I put an 8. If I put it back, it goes back. And that was multiplied by 2. All right. It's fine. It'll still do it. All right. Guys, I love that you're like completely infatuated with this. So guys, what this is though, when I think of a function machine, if I put a 4 through and it gives me an 8, what should happen the next time I put a 4 through? It should give me an 8, right? But like a function machine, no matter how many times I put that 4 in, every time it should get an 8. It should not change. Okay, that is when you know it is a function. If you put a 4 in, I get an 8, and I put a 4 in and I get a 7, it's broken, right? That is not a function. That is the easiest way for me to explain how a function, how to tell whether it is or is not. Okay? So a function, a relation in which each element of the domain corresponds with exactly one element of the range. That is the official book definition. I think of it as a function machine. If I plug it in, 8, and I get a 4, when I plug in an 8 again, I should get a 4. Right? It corresponded to one number. The 8 went to a 4. Okay? So number 3, determine whether it's a function. Think of the machine. I plugged in a -2, I got a -3. I plugged in a 4, I got a -3. Plugged in a 9, what happened when I plugged in a 9? I got a 0, and then I plugged in a 9 again, and I got a 1. What's wrong with my machine? It's broken. When I plug in these inputs, I better not get 2 possible things coming out of this. So is this a function? No. The machine's broken. I plugged in a 9 twice and got something different. That should not happen. All right, what about number 4? Is that one a function? Yeah, I plugged in a 1. I only had one option. I plugged in a 2, one option. Plugged in a 3, only one option. I plugged in a 4, it only came with one thing. Does that make sense, though? We're looking at stuff. Yeah, this is not bad, right? I told you, today is not bad. All right, what about number 5? Is that one a function? It's written a little different, but just look at your inputs. I plugged in a 0. I never plugged in a 0 again. I plugged in a... Is, yes or no? Yeah, this is. Because I plugged in a 0, I never plugged in a 0 again, so I'm fine. I never plugged in a -2. Like, what about 6? Why? Yeah, look, I plugged in a 3 and I got a 2. I plugged in a 3 and I got an 8. Mm-mm. Somebody broke the machine. You're just looking at that input. Yep. Think about that. Picture that machine that I just had up there, right? That you guys are so like enthralled with. Picture plugging stuff in. It was neat. All right, so number 7. I'll be honest with you guys, those of you that need to retake the air at some point, I know there's probably a couple of you in here that need to. This question, every time I look at an air test, is on there. This is not a hard question. But if you don't understand what a function is, you're like, I don't know what to do with that. So complete the first table so that it represents a function. Okay. So the only numbers I really care about are which ones? The inputs or the outputs? The input. What should happen with all of my inputs? They should all be different. Okay. 5. Does it matter what I plug in for y? Nope. I don't care. Pick a number. Doesn't matter. So the biggest thing, if it is a function, x should not repeat. Right? I don't want to put a 7 in and get a 2 and put a 7 in and get a 5. That should not happen. So if the second one, it says complete it so that it is not a function, then if it's not a function, what should the x's do? They should repeat. So if I would put another -2 here, what's the only thing that should not be listed here? A 5. Because if I put a 5 here, it's a function. Right? Because if I plug in -2, you get a 5. Plug in -2, you get a 5. That's good. But if I put a 9 there, it's not a function anymore. And I don't care. Pick a number there. Doesn't matter. Okay, so anytime you see the word function, your brain should be picturing that blue and red machine that we just did. Plug a number in, get something out. Don't let your machine be broken. Okay? Questions here, because this, every time I see the error test, this question is on there. Okay, so just shouldn't be too bad for you. Yeah. Yes. Yeah. All that matters is that input, whenever I'm plugging in, better be the same every time I plug it in. All right, another way to tell if it's a function or not is called a vertical line test. Which way is vertical? Up and down. Okay, vertical line test. If a vertical line passes through more than one point on the graph, then the relation is not a function. So again, I need you to stop and think about what that means. So I've got some red vertical lines drawn on here for you can see them. So if I would run this vertical line through this graph, notice it's going to hit here and here, which means it's not a function. It hit more than once, it is not a function. But now I want you to kind of take that a step further and think about what that means. My marker's being weird. Let's just say this is at, think about ordered pair. What would this ordered pair be? I would have went 1, 1, but okay. And then this one would be like, it's still 1 to the right, and then like -1. Think about the ordered pair. Think about the machine. I plugged in a 1, I got a 1. If I plugged in a 1, I got a -1. It shouldn't happen. So that's why the vertical line, because a vertical line is going to run through the same x value, right? Every point on this line is going to have 1 for its x. And if it touches more than once, that means the machine broke. It's going to pop out a different value for that y. So what about this one? Is this one okay? Yeah, this is a function. What about that one? No. It's hitting a point here and it's hitting a point here. So this is no. So like if you think about ordered pair, let's say that one's 2, 2, and this one might be like 2, I don't know, 6. I'm plugging in a 2 and it's giving me 2 possible answers, which is no good. Still doing okay? Still like the section? Awesome. All right, let me give you a minute. Go ahead and do these 3. The vertical line's not there. You got to picture your own, okay? All right, so number 9, function or no? No. If I draw a line, look at that. I hit it once there and once there. So this is a no, right? Because that would be like 3, -1. This would be like 3, I don't know, 4. So again, my machine's broken. I got two different things back when I plugged in a 3. Yes or no? Yes. That's close, right? They're like, yeah, they're kind of right above each other, but not exact. So that one's okay. And this one? This is a yes. It's got some curves to it, but it never gets to the point where a straight line is going to hit it more than once. What if I had a horizontal test? Then it would fail. But there is no horizontal test. Okay, it's just the vertical. All right, guys, the other part of this, yes, we can determine if it is a function or not. But then how do we use them and like why do we use them? It's kind of really the bigger thing. So another way to write a function, the y, instead of like being y equals mx plus b, you guys are familiar with that, right? The y is replaced by f, and then an x is in parentheses. That is read as f of x, or the function f of x. Okay, that is just function notation. It's just how we write it. It's just f of x and y can be used interchangeably. Whether it's f of x equals mx plus b or y equals mx plus b. It means nothing different, okay? It does not mean f times x. F is a name. Like if I was doing an equation figuring out how much flour I needed when I'm baking cookies, I might name my equation f of x, f for flour. I could call it c of x for cookies. Like you can, it's just a name. His name is Frank, okay? It's just a name, it's all it is, okay? And you can use whatever variable you want, you need, whatever when you're writing equations. The next section, which we'll do tomorrow, hopefully not tomorrow, hopefully Friday, because I don't want to be here tomorrow. But if the next section is story problems, we could write all of those with function notation, and then the variables we would choose would be based on what we're solving for. It just makes it easier. All right, but the way we use it a lot of times, and again, if you have to take, well, you all have to take the ACT, this shows up on there. If you have to retake AIR, this shows up on there as well. So write the input x and the output f of x as an ordered pair. So this has f of x equals this. So again, think of this as just like his name is Frank, right? It is just a name. It is no different than this being y equals my equation. Okay, it means nothing different. So it has three different values for x. The way that you usually would label this is f of -3 would be the first one. Because take a look, where did I just, this is x equals -3. What did I put it in place of? The x. So when I look at the equation, where am I going to put the -3? I'm going to put it where the x is. So -2 times -3 plus 5. So f of x, all that means is plug it in where the x is. And just tell me what it equals. Math-wise, is that very hard? What's -2 times -3 plus 5? That's 11. Thank you. I have one person who could do basic math in here. That's 11. Now, the directions want it written as an ordered pair. Well, what was your input? What did you put in? I put in -3, and what did you get out? 11. So that is the ordered pair for x equals -3. It's an input and an output. It is my machine, right? I am plugging in a -3, I push it through my machine, and I get an 11 at the end. Okay, it's a function. It's going to be, if I would plug in a -3 again, what would I get? If I would plug in a -3 again, what if I plug it in again? And again? Right? It's a function. It's a machine. My machine works. Every time I plug a -3 into that equation, I'm always going to get 11 no matter what. Okay? That is a function. Okay? It also wanted me to do 0. So f of 0. Again, plug a 0 into the Frank machine. That's all it's asking for, okay? It's just plug it into that equation. So -2 times 0 plus 5. Again, I am just plugging that in where my x is. What do I get there? That's just 5. So it said to write it as an ordered pair, 0 and 5. I put in a 0 and I got out a 5. My input and output, 0 and 5. Every time I plug a 0 in, what am I going to get? I'm going to get a 5 every single time. Okay? Plug in a 0, get out a 5. All right. And then I have 1/4. So f of 1/4. So negative 2 times 1/4 plus 5. Again, I am just putting that right where the x is. So what do you get? It is 4.5. Very good. So, as an ordered pair, what did you plug in? I plugged in a 1/4. What did you get out? I got 4.5. Marker's got a mind of its own. All right. So how are we feeling on function notation? It's just a name. F is not a variable. Do not think you're solving for an f. Does not mean f times 1/4. It's just saying, hey, this is Frank's machine. I'm plugging in a 1/4. What happens? That's all function notation is. Okay? So guys, try number 11 on your own. All right, guys, let's go ahead and go through this together. And let me talk about a couple things I saw going on that are common mistakes. Okay? So first and foremost, you guys see the negative out in front? Right? You see it's in front of the fraction. Now, I know I've talked to some of you at least about this. When you have a negative in front of a fraction, you can either kind of put that negative on the top, or you can put that negative on the bottom, but we cannot like put it top and bottom, because two negatives make a positive, so you've changed it. So me personally, I would just kind of think of that as that's a negative, excuse me, like a negative 3x right there. All right, so if I plug in a negative 5, I have negative 3 times negative 5 minus 1 all over 6. Now, guys, please listen, because I saw this happen and people were struggling. If you are using a calculator, we need to be careful how you type that in. Because if you just type in your calculator like this, negative 3 times negative 5 minus 1 divide by 6. If you type it in like that, guys, pay attention. Your calculator is doing negative 3 times negative 5 minus 1/6. It doesn't understand that you want that whole thing. Okay, especially those of you that have the just regular scientific calculators. If you want to do that, you'd have to put that in parentheses so your calculator knows, find this entire answer and then divide it by 6. Different steps is totally fine. If you're using the graphing calculator, remember green button, y equals, bring in your fraction, it does it top and bottom, so you can just type it straight in and it's fine. Or my own personal preference, I just do it one step at a time, which is what he just asked me about. So in my mind, I'm like, okay, negative 3 times negative 5 is 15. 15 minus 1 is 14. All right, so I kind of cleaned up my top first, so I have 14 over 6. But both of those numbers can be divided by 2. So simplified is 7 over 3. So as an ordered pair, I put in a negative 5, and I got out a 7/3. 16 over 6? You lost double negatives in there. Did you catch them? Okay. All right, so next is f of 0. Okay, take a look. Some of you only did the first one and stopped. It asked you to check it for 3 different numbers, so we got to do this 3 times. If I plug in a 0, that's negative 3 times 0 minus 1 over 6. So negative 3 times 0 minus 1, negative 1 over 6. That doesn't simplify, so I'm done. So I put in a 0, and I got out a negative 1/6. That's your ordered pair. All right, and then the last one is 1/3. Everybody loves a good fraction, right? So negative 3 times 1/3 minus 1 over 6. What's negative 3 times 1/3? What's a third of 3? So that'd be negative 1. A third of 3 is 1. So that's negative 1 minus 1 is negative 2 over 6. Right, so that I can divide those again both by 2 to get negative 1 over 3. So my input was 1/3. My output was negative 1/3. Questions on those? I know the fraction made them a little ugly, but process-wise, do we understand how the function notation works? It's just, if it was like g of x, you'd plug it into George, right? George's machine, and see what you get. Picture that machine. When it's a function, it's plugging it in the machine, you get something back. Every time I plug in a 2, I should get the same thing, right? If I plug in a 2 and I get something different, it's not a function, it's broken. What's up? Okay.